Hello, everyone. I hope you are doing well. Stay healthy for this last little bit of the semester. I'm going to do the questions that people asked me to do. So I have written them all down. I will attempt to go through them. There are about, I will show you, there are this many. So if you want to see which ones I'm going to do and see whether the one that you asked for is in here, there is the collection of them that I am going to do today. Again, the test is Friday and covers 3.1 through 3.4. So make sure you're comfortable with 3.4 stuff. Not a lot of people ask questions about 3.4, but I have one good one that's very much like the one on the test, or at least one of them in here. So you should be prepared. Also note that I did I did email you, a list of the topics for the test in the same way that I do for every test, where I sort of outline, okay, these are the kinds of questions you should expect. And this is what you can anticipate out of that. So you can look at that as you prepare as well. All right. So we are going to start here with 103C. So this is find f prime of x if f of x is this. So we remember f prime of x is the limit as h goes to 0 of f of x plus h minus f of x divided by h. Okay. I should note, by the way, really the way this was actually worded in the homework, 103C was just find that, and then 104C was find this, but I'm just going to go ahead and do it all here because why not? It's one of these instances where it's probably going to be messy enough that it's worth simplifying f of x plus h first. So that is going to be x plus h minus 2x plus h squared, like that. So we can simplify this. So that is going to be x plus h times x squared plus 2xh plus h squared minus 2 times x squared plus 2xh plus h squared, which is, if I write that out, okay, so now that's x cubed plus 2x squared h plus xh squared plus x squared h plus 2xh squared plus h cubed minus 2x squared minus 4xh minus 2h squared. Okay, and here we do have... Oh, maybe we don't actually have any terms to combine. I was thinking maybe we'd get some terms to combine, but I don't think we actually have any terms to combine. So we have this mess. So now when I go to find f prime of x, it's the limit as h goes to 0 of all of this. I'm just going to draw that with an arrow, minus, and then f of x, which is x cubed, and then this will be plus 2x squared over h. Be careful with the minuses, as always. Here, when I subtract f of x, I end up with a minus x cubed and a plus 2x squared. And in particular, that's going to cancel this term, and it's going to cancel that term. And so on my next line, I'm going to have equals the limit as h goes to 0 of 2x squared h plus xh squared plus x squared h plus 2xh squared plus h cubed minus 4xh minus 2h squared, that whole giant mess, all divided by h. And fortunately, every term here I can divide by h, so I get to do that. So this becomes the limit as h goes to 0 of, so this first piece here, oh, I see I lied when I said there weren't any terms that combined. Those two terms combined. But we'll handle it at the end. So this is going to be a 2x squared plus xh. Remember, you have to divide the h out of every term. Plus x squared plus 2xh plus h squared minus 4x minus 2h. And if I look at the limit as h goes to 0 of that, that's going to basically drop out all the terms with an h in them. So the 2x squared is going to stay the same, plus the x squared is going to stay the same. Sorry, that's an x squared. This term's going to go away. That term's going to go away. That term's going to go away. I'm going to have a minus 4x, and that term's going to go away. So this is ultimately 3x squared minus 4x. And that is our answer for that question. Okay. The first few questions people had were all of the this flavor of practice. Basically the, and this is very understandable, the messier algebraic versions of this. So I'm just going to do a few of these, and then we'll do some other things. So next up we have this one. So here, when I write down k prime of x, so the limit as h goes to 0 of k of x plus h minus k of x divided by h, which is going to be the limit, h goes to 0, 1 over h times. And so this will be x plus h all squared divided by 2 times x plus h plus 1 minus x squared over 2x plus 1. Okay, so this h goes to 0 over h times. Okay, and I'm going to multiply out this thing in the numerator before I combine these to be one fraction. I'm not going to bother multiplying out the denominator because we, as a general rule, don't multiply out denominators unless we have an excuse for doing so. Plus h squared over 2 times x plus h plus 1 minus x squared divided by 2x plus 1. The limit as h goes to 0, 1 over h times. Okay, so now it's going to be one fraction. The denominator is going to be 2 times x plus h plus 1 times 2x plus 1. And the numerator is going to be x squared plus 2xh plus h squared times 2x plus 1 minus x squared times, and then this is going to be times 2x plus 2h plus 1. Okay, I will continue this onto the next sheet of paper from there. So this is the limit as h goes to 0 of 1 over h times. Okay, so I got to write out this first piece. So that's going to be 2x squared, sorry, 2x cubed, when I combine those, plus x squared, plus, and then this will be 4x squared h plus 2xh, plus 2xh squared plus h squared minus, and so that'll be a minus, sorry, you can't quite see that. That'll be a minus 4x, or sorry, minus 2x squared, no, minus 2x cubed. That'll be a minus 2x squared h, and that will be a minus x squared. All of that's sort of in the numerator. And all of this is divided by 2 times x plus h plus 1 times 2x plus 1. Just looking for things that potentially cancel, I see a 2x cubed and a minus 2x cubed, and I see an x squared and a minus x squared. And again, conveniently, after I've done that, every term that's left has an h in it, which is what I'm looking for. So I can actually do my step where I divide through by h. So when I do that, I'm going to be left with a limit as h goes to 0 of, and it's going to be a big fraction. I'm going to have the 2 times x plus h plus 1 times 2x plus 1 down here. And in the numerator, remember, I'm dividing everything by h as I write it. So when I divide this by h, I get 4x squared. Plus, when I divide this by h, I get 2x. This will be 2xh. This will be h. And this will be minus 2x squared. Okay. And now I take the limit as h goes to 0. And so that is going to make these two terms here disappear. So that is going to give me 4x squared plus 2x, and then minus 2x squared, all divided by, and then this is just going to be 2x plus 1 times 2x plus 1. And so once I've written that out, that'll be 2x squared plus 2x divided by 2x plus 1 squared. And so that will be our answer. Okay, very similar question next in terms of what it is going to ask us to do algebraically. So same question of find the derivative. So if I go to look at that, my j prime of x is going to be the limit as h goes to 0 of j of x plus h minus j of x divided by h. It's going to be, that is h goes to 0, 1 over h times. So it'll be x plus h here in the numerator divided by x plus h squared plus 1 in the denominator minus x over x squared plus 1. So this will be the limit. H goes to 0, 1 over h times. And so now I need to put these over this common denominator, which in this case is x plus h squared plus 1 times x squared plus 1. So this will be x plus h times x squared plus 1 minus x times, and then this, I'm going to go ahead and write that out as x squared plus 2xh plus h squared plus 1 as I copy it there. I've got my closed parentheses hanging out all over there. Okay, so let's continue multiplying all of this out. I've got a 1 over h times here. So that'll be an x cubed plus x squared h plus h. And now I've got a minus x cubed minus 2x squared h minus xh squared minus x over there. When I multiply this out, again, always be careful about the minus sign with the distributing things like this, divided by x plus h squared plus 1 all times x squared plus 1. Okay, so we look for our stuff that canceled, hoping that there is some of it. And I see an x cubed that cancels with an x cubed, and an x that cancels with an x. And so I do my sanity check, and once again, I am left where I want to be, which is to say that I am left with only terms with h's in them in the numerator, so I can divide through by h. So when I go ahead and I look at that, this is going to turn into the limit as h goes to 0, 1 over h times, oh, sorry, I'm going to divide through by h before I do that. So I'm not going to have a 1 over h times. I'm just going to divide through by h as I copy these. So that's going to be an x squared. That's going to be a 1 It's going to be a minus 2x squared. That's going to be a minus xh. And that is it. There's only the 4 terms there left in the numerator. And we've got the x plus h squared plus 1 times x squared plus 1. Okay, and now I'm going to take care of the limit as h goes to 0 part. Looking at that to make sure you can still see it. I think if I click the button, it'll look a little better. There we go. So now when I take the limit as h goes to 0, it's going to make this piece in the numerator disappear, and it's going to simplify this piece down here. So it's going to become, and so these two together are minus x squared plus 1, and again, this term disappears, divided by, and so that will be x squared plus 1 times x squared plus 1. So this will be, if you want to write it this way, 1 minus x squared, you can leave it as minus x squared plus 1 if you prefer, divided by x squared plus 1 squared. Okay, so 106C was the next question that I was asked about. So that is here. So in this question, you're given both the function and its derivative. So we don't have to find a derivative in this question. We're just given the function, given the derivative, and we're asked to find the equation of the tangent line. Okay. So to do that, I need 2 things. I need a point and I need a slope. Okay, so the point has x-coordinate 1, that's given. The y-coordinate here is supposed to be h of 1, which is e to the 1 squared, which is just e to the 1 minus e to the 1, which just happens to be 0. So the point here is 1, 0. That is my point. And my slope, that's what the derivative tells me. So this is h prime of 1. And again, I was told the derivative, so I don't have to compute anything here. So this is 2 times 1 times e to the 1 minus e to the 1. Okay, and so that's 2e minus e, that's e. Okay, and note here, for the point, I plugged the x-coordinate into h, and for the slope, I plugged the x-coordinate into h prime. So it's important that we get those 2 right. But once we have that, we know that our line looks like y equals ex plus b. We just don't know what b is, but we can plug in our point, 1, 0, to fix that. And so that will give me 0 equals e plus b. So b is minus e. And so that means my tangent line is y equals ex minus e. Okay, so that is our equation for this tangent line. Okay, next up, we are asked to find the intersection of the tangent lines of 1 over x at 1, 1 and minus 2 minus a half. So here to start, we get to find h prime of x. Okay, you'll recall the reason why we started doing questions like this is that it lets us economize finding slopes, because I can find the slope to both of these by only computing one limit instead of having to compute a bunch of limits. So this is the limit as h goes to 0 of, and so it will be, oh, I guess I shouldn't call this h of x, huh? That probably was a bad idea. I'm just going to change the name here to a capital H, only because I'm about to write this. It will possibly be slightly confusing if there's 2 h's flying around. So we've got capital H, the function, and lowercase h, the thing that I have this limit as h goes to 0. You can change the letters around whatever way you want for this. But this will be the limit as h goes to 0 of 1 over h times. And so it will be 1 over x plus h minus 1 over x. And so that will be the limit as h goes to 0 of 1 over h times. And so this will be x plus h times x. And the numerator here will be x, and then minus x minus h. If you look at that, and again, that is because of this minus sign getting distributed, so I end up with minus x and minus h. Okay, and these cancel. So now I can cancel the h's once I've done that. So I've got now a limit as h goes to 0 of minus 1 divided by x plus h times x, which is minus 1 over x squared. Okay, so that's my derivative. So now I need to find the tangent line at 1, 1. Well, I know it's going to look like, I need its slope, I should say. So its slope, remember, is given by h prime of 1, which by our formula here is minus 1. So our tangent line here has the flavor y equals minus x plus b, and we can plug in 1, 1 to figure out what is going on here. So that will give me 1 is equal to minus 1 plus b. So that tells me that b is 2. So this line is actually, if I want to write down the final answer, y equals minus x plus 2. That's my tangent line. And then I do the same thing at minus 2 minus a half. So here my slope is h prime of minus 2. So that if I look over here, that is minus 1/4. So now my equation looks like y equals minus 1/4 x plus b. And I can plug in the point I want. So that is plug in minus 2 minus a half. And when I do that, I get minus 1/2 equals minus 1/4 times 2 plus b. So that itself is minus 1/2. This is a minus 2. Sorry. It would have worked out nicer if I had gone with my erroneous copy, but actually this is supposed to be a minus 2. This is minus 1/2, that's plus a half, so that ends up giving me that b is minus 1 after I subtract this 1/2 over to that side. Okay, so my two lines, the two tangent lines that I'm looking at, are y equals minus x plus 2 and y equals minus 1/4 x minus 1. And so when we go to find the intersection of these 2 points, remember that we do this by setting these two things equal to each other. So this will be minus x plus 2 is equal to minus 1/4 x minus 1. So I'll move this 1/4 x over here, so that'll leave with a minus 3/4 x. And move this 2 over here, equals minus 3. And so now I need to multiply both sides by minus 4/3. Those all cancel, and we get that x is 4. Sorry, there shouldn't be an equals there. We get that x is 4. And when x is 4, we can plug it in here to see that y is minus 2. You could also plug in the 4 there to see that y is minus 2. And so the point you're ultimately looking for is 4, minus 2. Okay, and there's a lot here that you can check against the given graph to make sure that it makes sense. So you can check that both of these lines have negative slope, for example. You can check that this line has a positive y-intercept and this line has a negative y-intercept. And you can check that the point you end up with is in the part of the plane where x is positive and y is negative. So you can have a lot of confidence by the time that you do all of this work that everything works out. Okay, so the last question that was sent in by email was this one. So we're given a graph here, and we are told that this graph is made up of three pieces. One of those pieces is a line over here. One of those pieces is a piece of a parabola here in the middle. And one of those pieces is another line over here. Okay, so when we go to draw our graph of the derivative, we don't want to do something similar where we do this. Okay, so here are the pieces. And so remember, it makes the most sense to line up the derivatives graph vertically because the x values are the same. Now I'm going to start with the line pieces. So remember, the derivative of a line is a constant. So when I go to graph the derivative of a line, it's always going to be a horizontal line. And so the only real question to keep in mind is it positively sloped or negatively sloped? And so in this case, it's positively sloped. So I can draw in something like that for this. Okay, this is also a positively sloped line. But if you squint at it, you can actually see this line is steeper than this one. So the derivative here is also going to be a horizontal line, but the horizontal line is going to be up here above that horizontal line. Right. And again, the reason for that is because this line has a steeper slope than this line. Another thing we look for whenever we are sketching a graph is look for spots where the derivative is 0. We do have one of those right here. So I can copy that down there. And the reason the derivative is 0 is not because the y value is 0. It's because the slope of the tangent line here is 0. Right? So here the y value is 0, but notice the derivative is definitely not 0. Okay. So we also can mark that in this piece between here and here, I know the derivative is going to be positive because the slope of all of these lines is positive. And over in this piece, it's going to be negative because the slope of all of these lines is negative. There we go. So I know that this thing is going to be positive here and negative here. And also, the nice thing about parabolas, remember, is that anytime you take the derivative of a parabola, the answer is always a line. So this is some sort of line that goes through this point, and you actually know the line has to be positively sloped. And the reason you know the line has to be positively sloped is that it has to be positive here and negative here. So like that line can't possibly work because this line is positive in this piece and negative there. Okay, so I'm looking for something like this. Now, what you can actually see if you look closely here is that actually at this point where the graph transitions from a parabola to a line, they actually have the same slope at this point. So actually, this part of the graph should line up because I'm getting the same slope on the left as I am on the right. So actually, my line, when I draw it in, it should pass through these 2 points. So it should look something like that when I go ahead and draw that in. And the only thing I can do to sort of finish this up is now notice that at this point there's a jump in the graph. So actually I need to put a hole on both sides here to indicate that there is no derivative here at this point because the left derivative and the right derivative don't agree. And in that way, it works just like a limit. Okay, give me a second to check and see if anyone sent in an extra question while I was recording this. Okay, I don't have any more, so that looks like all from me for today. I hope this is up by class time tomorrow. I don't 100% promise, but I think probably that is plausible. Email me if there's anything else I can help you with. It is very possible that on Friday I will come in and just wear a mask and put a test in front of you and then run and hide in my office until you're done. But we'll see exactly how that ends up working out. But anyway, send me an email if you have any subsequent questions. I probably won't record another video, but I can at least briefly answer if you have a question about logistics or anything like that. All right, but thank you all. Again, I hope you all stay healthy, and I hope that I am able to be with you again very soon. I suspect, hopefully, just based on my experience with colds, hopefully I'll be better by Monday, but who knows? Hard to predict. But anyway, thank you all again, and I'll see you all real soon.